we begin word problems. So, modeling with equations. You're going to have a short assignment you can start working on during this hour. Yesterday we were able to do a few things in second hour, so second hour is a little bit ahead of you, but we'll catch up during this time. There are some tricks of the trade. These are things that you have seen before. We'll see how well you remember them now. Okay, consecutive numbers. If I have a given number x, what would be an expression to state the number right after x? What's the next number after x? X plus 1. Very good. What's the next number after that? X plus 2. So those are consecutive numbers. I should say consecutive integers, excuse me. Consecutive evens. How do we ensure that a number is even? What could we do to it to make sure it's even? What? Very good. Except if I have 7 and I divide by 2, I get 3.5, right? So instead of dividing by 2, I could take a number like 7 and multiply it by 2. Very good. So I'll take a number and we'll multiply it by 2. 2x. Any number you choose for x, an integer, any integer you choose for x, if you multiply by 2, you will get an even number, I promise. What will be the next even number after that? Plus 2. 2x plus 4. Gotta skip the odds, right? Okay, so if I make a number even, say 2x, what would I do to it to then make it odd? Add 1. You're so smart. So proud of you. Sarah Savvy. Sarah, were you in my class yesterday? Interesting. Interesting. Another person skipped my class. Oh, whatever. So, find 2 consecutive squares whose sum is 613. So this is the type of problem that we have. 2 consecutive squares whose sum is 613. Well, I have one square. We'll say x. So we will square that. What would I write for the next consecutive square? So 8 squared. What's the next square after 8 squared? 8 squared is 64. What's the next perfect square after that? 81, which is, so 8 squared, then 9 squared. Or x plus 1, that quantity squared. And if I sum those, it says find 2 consecutive squares whose sum is 613. Equals 613. That's what I want to do. How to solve, how to solve. What would you do? You masters of algebra, as I just graded your last test. FOIL, very good. X plus 1, quantity squared. X squared plus 2x plus 1, as I FOIL that out, equals 613. X squared plus x squared is 2x squared plus 2x. I'm going to subtract the 613 over because in order to solve a higher degree polynomial, we have to set it equal to 0. So I have minus 612 is equal to 0. That's Spanish for 0. What to do, what to do, what to do. Starts with F, rhymes with actor, factor. So we take out a 2. We're left with x squared plus x minus 306. Beautiful. All right, so now I just need 2 numbers that multiply to negative 306 that add to positive 1. Any guesses? They got to be pretty close together, right? I mean, they just differ by 1, right? They only differ by 1, so why don't we try this? Let's go like this. Let's take 306. Let's take the square root of 306. Square root of 306 is 17.49. Maybe 17 times 18 works. 17 times 18. Oh, hey, what do you know? That was impressive. Sarah says so we'll believe her. 2 times x plus 18, x minus 17. What are my solutions to that equation? Negative 18, positive 17. Is that my answer? What? Nope, because I have a 2 out front. If it was an x, then I would have a 0. So I have, it's a second degree polynomial. I should have 2 solutions. They are negative 18 and 17. That's what it gives me, but are those necessarily the answers? I should go back and read the problem. I'm looking for 2 consecutive squares. Are these perfect squares? No. My perfect square is x squared. All right? So these are the x values, so I should plug them in. What's negative 18 squared? 324. What is the next one after negative 18 squared? Negative 17 squared. What's negative 17 squared? 289. So those are 2 consecutive squares, 289 and 324. So we plugged in negative 18, and we come up with those 2. If we plug in 17, watch what happens. What's 17 squared? 289, and then 17 plus 1 is 18. Squared is 324. So these are your answers right there. Any questions? Going once, twice, thrice. Try a new problem. Our goal is to get through the first 4 examples. Find 2 numbers whose sum is negative 3. We'll do negative 4. And whose product is negative 96. Negative 96. 2 numbers. What should we call those 2 numbers? X and Y. Very good. Let's do that. X plus Y is negative 4. Whose product is negative 96. How would I write a product of negative 96? What would I do there? X times Y is negative 96. And I need to somehow take those 2 variables and solve. Now, I can't solve 2 variables. I have to create 1. How will I create an expression that is 1 variable? Good idea? That won't work. Can't plug in 0. I want to solve for Y. I'll solve for Y. Or X, either one will work. Let's solve for Y. Y is equal to negative 4 minus X. What can I do with that negative 4 minus X? Take it and plug it in for Y right here. And if I do that, I will have a new expression. New expression reads X times negative 4 minus X is equal to negative 96. That's what I'm now trying to solve for. Negative 4x minus x squared equals negative 96. How do I solve a polynomial of higher degree? I set it equal to 0. So we'll add those over. We get 0 is equal to x squared plus 4x minus 96. Two numbers that multiply to a positive 4, but added, or I multiply to negative 96, but add a positive 4. Factors 96. What do you got? $12 and 8. So I have a plus 12. I have a minus 8. So my solutions to this quadratic are x equals a negative 12 and a positive 8. Have I answered the question? Do those add a negative 4? Do they multiply a negative 96? Yes, so the answer is these two numbers, negative 12 and positive 8. Any questions on that? I'm trying some of the harder problems, I think, so that hopefully the ones in your assignment are a little bit easier. I just have 5 problems I want you to start working on tonight. Because I know you guys have big plans for homecoming. You're excited? I do too? Oh. What are the plans? I didn't get the memo. So, like, where's everybody meeting tonight? Okay. I didn't get it. I didn't know if I wasn't invited. Am I purposely being left out of this? Because one time I did this, and the students said that they were meeting at the mall at 6 a.m. on Saturday morning, and then I showed up at 6 a.m. on Saturday morning, but there was nobody there. They all thought it was funny. I thought it was kind of insensitive. Don't you think, Hannah? Why are you laughing? Oh, variable at 5 o'clock. Prez? Is that a lie? Prez is coming. Bringing out secret security. All right. Well, hopefully you guys won't have too much homework tonight. I hope I don't add to it, but I do have 5 problems, and we'll give you some time in class to work. So, this one's a little bit trickier as people try to work through these ideas of interest. Tom has $9,600 to invest, and he could invest it in different portions. For example, he could invest $9,000 in one spot, $600 in another. He could invest, say, $4,800 in one spot, $4,800 in another. He invests a portion of it at a rate of 4% a year. What does that mean if he invests at 4%? It's going to earn, hopefully, 4% of that value that he'll get back. So if he invests $100 at the end of a year, he'll hopefully have $104. So the rest he invests into a riskier market that earns him 10% a year. And his total earnings of the interest were $528. He made $528 over the course of that year on his interest. So not who, but how much did he invest in each place? So that's what we want to know. And this is where often students have a difficult time kind of getting started. Before we even start writing an equation, let's just write an expression. He has a certain amount of money, right? Certain number of dollars that are invested at 4% interest. And he gets money from that. Whatever the interest is times the dollars, that's how much money he's going to get. Plus, he's got more dollars that's invested at 10% interest. And that's equal to his total earnings in interest. So, do we know how many dollars he invested at 4%? Nope, that's what we're trying to figure out. We'll call it X. X times 4%. What's 4%? 0.04. Very good, Andy. Plus dollars at 10%. What's 10%? 0.1x. Whoop. Do we know if it's the same amount in each one? No, so we can't call it X. We got to call it Y. And that's equal to, what's the total amount he got back on his investment? 528. I have 2 variables. I can't have 2 variables. So I need to come up with another expression and solve. X is the amount he has in one spot. Y is the amount he has in another spot. What do those have to add up to? $9,600. Nice job, Casey. $9,600 is what, if we were to put those together, is what it has to add up to. So I need to solve for one of these. I'll solve for Y. Y is equal to 9,600 minus X. And I'm going to take that and I'm going to plug it right in here for Y. And that will give me an equation that only has one variable. In particular, it only has X. So we have 0.04 times X plus 0.1 times 9,600 minus X is equal to 528. And that is my new expression that I want to solve. So I distribute my 0.1. I have 0.04x plus, what's 0.1 times 9,600? 960. Very good, Hannah. Minus, what is 0.1 times x? 0.1x equals 528. Are there any like terms we can combine? 0.04 and 0.0 or in 0.1? A negative 0.1, excuse me. What does that give me? Negative 0.06x plus 960 equal to 528. Negative 0.06x is equal to, subtract the 960 over, what do I get? 432. Negative. Divide both sides by a negative 0.06. And x is equal to, what's negative 432 divided by negative 0.06? $7,200, and this is dollars, we know that. Have I answered the question? Question is, how much did I invest in each spot? I have a 4% interest investment, and I have a 10% interest investment. So what does X stand for? The amount at 4% or the amount at 10%? 4%. 7,200. How did I know that? If you look up here at our original equation, we have 0.04 times X. So that's 4% is X. And then the 10% would be the difference from $9,600, which would be $2,400. That is my answer. Any questions on that one? I think you're pretty smart, huh? All right, let's try one more. Mallory, what do you think? Is this stuff too easy? Should we just skip it because we all really just know it that well? No need. Oh, you want to do it? Okay. Should we do all 100 problems in the book? Mallory, have you seen Lord of the Rings? You were forced to watch it all. Raise your hand if you would enjoy once a year watching all 3. Oh my gosh, only 4 of us. 5. Okay, all right. So Logan, Danny, Lucas, Hannah, and myself and Jesse, we're all gonna go watch The Hobbit when it comes out. Oh, you want? Oh, so you weren't gonna raise your hand for Lord of the Rings, but you want to see The Hobbit? Oh, all right, okay. Oh, it's great. It's good stuff. It's good stuff. You saw what? The cartoon version? That does not count. That does not count. I could watch the Lord if it, you know, sometimes you're watching TNT and all of a sudden the Lord of the Rings is on, for like 5 straight hours. I could turn it on in the middle of any part of all 3 and just watch. It's great. If you could be any one character in the Lord of the Rings trilogy, who would you be? Aragorn? I'd be Gandalf. I want to be a wizard. I want to be a wizard. I want to be the white wizard though. I don't want to be Gandalf the Gray. I don't want to be Gandalf the Gray. All right. They looked like they were falling asleep, Chrissy, so I decided to start talking about the Lord of the Rings, and all of a sudden they just started chattering. Apparently they have Lord of the Rings costume parties where they all dress up. They're like, Riz, you want to tell us what's going on? Huh? I can't believe, so neither one. Oh my gosh. Oh, oh no, Riz, isn't there like a little person? It's all about the Hobbit community. Come on, where do the hobbits live? They live in the Shire. They live in the Shire. And a long time ago, Gandalf came and grabbed Bilbo Baggins and took him off to the Misty Mountains, and that's where we had the Hobbit. And now he comes back to the Shire. The Hobbit is like the beginning to the Lord of the Rings trilogy. Yes. All right, back to math. Thank you, Larissa, for getting us back on track. All right, last problem. A rectangular garden has a perimeter of 288 feet. If the length is 4 more than twice the width, what are the dimensions of the garden? Now, let's stop thinking about how you would approach problems and start thinking about if you had to teach them, what would you tell somebody to do first? What? Draw it. Yeah, let's draw a picture. You're so smart. We draw a picture. We draw a rectangular garden because then I can start to label stuff. I can get a visual. This is how you learn. Where are you going to plant it? No. You know, in the Lord of the Rings, the Fellowship of the Ring, they get in trouble for stealing carrots from the garden. So, all right. We have width. We have length. Right? And if we add them all up, we're going to get, it says 288. But there's an important piece of information here. It says the garden has a perimeter of 288, but the length is 4 more than twice the width. So I could say the length is, how do I write 4 more then? 4 plus 2w. So now, if I just take that and put it here, length is 4 plus 2w, and length is 4 plus 2w. Now I have one expression that just has all w's. And so if I add up all those sides, w plus 4 plus 2w plus w plus 4 plus 2w is going to be equal to 288. Square it? How about double it? Don't square it. It's a rectangle. Really bad math joke, but, you know. All right. Yeah. Somebody put a quarter in her. All right. How many W's do we have? Not 5. We got 6. W plus 2W is 3W plus W is 4W plus 2W is 6W. Plus 8 is equal to 288. Subtract the 8. 6W is equal to 280. You divide both sides by 6. W is what? What do you got, boss? 46 2/3. Very good. So the width is 46 2/3. Does that answer our question? Kind of. We also have to know the length. How do we find out the length? Plug it in. So 2 times 46 2/3 would be 93 1/3 plus 4 is 97 1/3. So it's 46 2/3 by 97 1/3. And that's that. What do you think of that? All right. Here you go. Here's some problems. There's 4 problems I'd like you to get started with. Page 70, numbers 9, 11, 13, 16, and 22. Now, 4 out of the 5 of these pretty much follow exactly what we've been doing in class. One of them does not follow exactly what we've done in class. You might have to use some outside-the-box thinking, but that is good for you. And please don't feel like you got to get a problem right on the first try. Mathematics is about doing things incorrectly all the time and making, corrections from it and then doing it the right way. So don't worry if you do it incorrectly, but give it a shot. And if you need my help, I will help. But please look at your notes, look at your book. Ask myself, ask Chrissy, we can help you out. You got 12 minutes, go ahead and get started.